Hello, in this session we will talk about concrete design in ADA. So we start a new model. For the first step in project configuration, we need to define our preferences. That default is fine. The analysis, our analysis will be a nonlinear one. And the other defaults here are okay. Also, because it is a concrete design project, so you can change different default values here. For example, the rounding of dimensions, optimization, shear maximum number of stirrups, and other objects here. But for this project, for now, we are keeping the defaults. So I'm going to click OK. First step is to define the geometry of model. So I'm going to show you a fast way of defining the nodes and supports in ADA. So you need to just click on the node activation icon here, go to the spreadsheet or Control H, and here you can add the nodes fast. I mean, node number 1, it's a normal one, and the coordinates will be x10, y3, z0. The second node, number 2, it's a normal node, x0, y3, and z0. Third one, it's a support, so I select support. It will be all 0, 0, 0. And node number 4, again, it's a support. The x will be 10, y0, and z0. So it will be a two-dimensional frame here. I have the nodes here and the supports. So next step will be defining members between the nodes. So I'm going to activate the member. Add icon. And I'm going to add the columns. So for the column properties, I'm going to select a rectangular one, concrete, rectangular sections. And it will be a 350 by 350. Okay. For the material, it will be 30 megapascal concrete. So this material. For the dead load, I'm going to assign the dead for as self-weight of the column. And because it's gonna be a design, so I'm activating this here. So just hit OK. So this is the first column, and I'm going to add the second column. So we have the same properties. Okay. And next I'm going to add the beam. So just clicking the starting head node. So for the beam, I'm going to use 350 by 650. Will be 350 will be width and 650 will be the height. So I'm going to use this one. Okay. Material will be same and everything is same. Also the end conditions will be fixed. So okay. And here I want to see the members as 3D, so 3D. And as you see, I have my 2D frame. Okay. The next step that we need to do in a concrete project is to defining of rigid extensions for members. So ADA needs these rigid extensions in a concrete project to place the rebars, and we have a way of doing it in ADA automatically. So the best way is to select the all members, and we can go to Tools, Members, and Generation of Rigid Extensions. So here ADA will automatically generate the rigid extensions at end connections of the members. So click OK. And if we check the members here, for example, my beam, in Connection tab, as you see, ADA defined a rigid extension of 175 to both ends of my beam. And also we need to define two other properties for our concrete design. So I use all of the members properties. In the concrete tab, we need to select this to check for shear at the face of the member. So it's a criteria. You can select for both of them. So in this project, I'm using this criteria. And for the second criteria, I'm just using the positive bending for proportioning of longitudinal reinforcement. So, okay. And if you want to check the type of sections, you can always use members and shape. So you will have the members and type of shape viewed in the display. Next step is to define our concrete specification. So to define it, we go to Structure, Specifications, Concrete, and as you see here, we have some of them already defined. So to start a new one, I'm going to delete all of these to show you how to define a new one. So it's technically like this: general, add. So you give a number or name. I'm going to name it A23.304 design. So it will be the Canadian code CSA A23, so this is fine. I want it as design. You can also use sticks according to your license. And all other options, I mean, you can activate all other options from here, as you see. So you have so many options to define your code. I also change this for standard. And also I'm going to define another one for verification. We have already spoke about differences between design and verification. So just Control-C copy and Control-V paste. I'm going to paste it, and the second one will be just for verification. Okay. You always have the opportunity to change the main reinforcement that ADA will use for design. For example, in this model, I want to use just 25M and 30M as my main reinforcement. And also you can change other. Okay, we need to name the we need to change the name because they are same. So I'm going to change it for 30. Okay, and you can also change other options here. For example, transfers, reinforcement, material, optimization method, number of layers, and other stuff. So for now, we are leaving all these defaults the same. And if you have a slab design or other shear wall design, you can always change the values and properties for those kind of design. So right now we have just these two, and I click OK. Okay, the other step that we need to know in concrete design is the continuous systems. And continuous systems is a icon that you see here. It's a continuous system, and it's normally for concrete design when we use and when we want to have continuous members, to have continuous reinforcement and stirrups, and their behavior will be a continuous beam or column. In that case, we normally define those members as continuous members. So if you select this here, the continuous system, and double click the beam, as you see, ADA have already defined the continuous system. So in most of the concrete projects, when you build your members, ADA automatically define continuous members for that. And if you want to do it by yourself, we have a tool here. So for example, if it's not already a continuous system, you can select the members and go to here, this icon, create a continuous system. So in that case, ADA will create the continuous system. But here, as I already explained, because it's a concrete project, ADA has already built the continuous systems. So it will use this continuous system to place the rebars and reinforcement in the concrete menu. So if I select all of the members or continuous systems here, as you see, I've activated here, and hit Ctrl H to bring up the spreadsheet. As you see, all of the continuous systems are defined, and as you see, this is the specifications that I've already defined. Type is beam column. It's there an interaction that for columns is bending and compression, for the beams only bending. And the other properties that you can always define for the continuous systems all are here. So you can change the covers, right cover, left cover, bottom cover, and top cover, and other properties. For example, right now I'm going to define the covers, top cover here, for example. For the beam, I'm going to put it top cover at 30 millimeter. And for the columns, it will be 40. Bottom cover will be same. And also same for the left and right cover. So we have defined our covers. So I'm going to click OK. In this stage, we need to define some load cases. So load cases, definition. We have the dead already there, so I'm going to add a wind. And a live load. Okay, and in the next stage we are going to apply those. So for the live load, we need to change to load case mode, live. We save the project, and afterwards we select the beam. It will be a distributed load of -50. And okay, so this is the live load. And after that I'm going to apply a wind load. So the wind load will be applied to this column. It's a triangular distributed, so it will start from 0 to 20. And the projection, we want it to be on weak axis. Okay. So as you see, this is the wind load. In the next stage, I'm going to generate the load combinations. So load combinations generator. So I'm going to use MVC 2005 and generate. Next. So in this window, everything is okay. Next. These are the load combinations. And finish. So we have the load combinations generated. Okay. So to do the design, we just click on this button here, Analysis and Design, save the project, and design is started. So calculation is completed here, close. And we always check for the summary if everything is okay. Yeah. So as soon as the analysis is done, as you see, for as default, ADA is already activated the rebar placement mode. So we can always go there and check the reinforcement that we will do it. But before that, in results, we want to know the preliminary design results. So we can go to results, structural design, and concrete. As you see here, for our beam, the design load rate is 90. And for columns, we have 79. And as you see, for the interaction, it's a bit high number. You have the reinforcement here. Okay. As you see, because we had some problems here, in the columns, and they need to be changed, so they're actually small. So before checking the reinforcement, we need to change the dimension of the columns. So what we are going to do right now is to change the columns for 350 to maybe 500. So I'm going to select columns, go to the structural mode, Control H, okay, member mode, Control H, as you see, the columns are 350 by 350. We need to change them for 500 by 350. So I'm going to use 350, 500 by 350. Okay, for this one also. $500 by 350. Okay, as you see, they are not well oriented against the wind load, so I'm going to rotate them. Control H, beta angle 90 degrees. So right now, as you see, they are well oriented. We are going to perform the design again. Yes. Okay, design is complete. Check for summary. Everything is okay. And afterwards, we need to check for structural design concrete column. And as you see right now, it's okay. It's on 94. Before it was on 140 something. So right now we know that the size is okay and the design will be okay. So, okay. To see the rebar placement for columns, we can always click the first column. We are already on rebar placement, so just double click the first column. So you see a new window has opened. You click OK, and this is the reinforcement that ADA designed for this column. So this is a section. It has used 16 30Ms. And you can always activate the results from the view options here, or O, to see the detailed results on columns. So I'm going to activate these results. Axial. Yes, and for the dimensions, I need to see all of them. So they're already activated. Okay. So as you see here, I have all the curves and results on my column. This is the interaction curve. Dimensions. And this is the curves for axial forces. This one is the shear resistance, shear force. This is for the MFX or bending force. We can have other results also. MFY, MRY, okay. And VRX, VSV, FX. So as you see, these are the results for column design. For the sections that you see here for the column, you can move this to have the section. So for example, if I click on this icon here, click this, and you can always click this icon, sorry. You can change the place of the section. And also you can add new sections from here. Rebar placement, cross sections. definition. So let's say if you want another cross section, so you add number 2, the same coordinates, Control C, Control V, and you can always change the place of your section. For example, here I put 500. To change this number to 500. Okay, and as you see here, I have another section to here, and you need to move this way like this. So you can place it here. So this is section 1 and this is section 2, and you can define whatever section or what place you want for the column. To check for reinforcement, you can always double click on them. So let's say if I double click on this main reinforcement, as you see, you have the type of reinforcement, the diameter, the shape, and the coordinates of this main reinforcement, or this one, as you see. Also for the stirrups, you can double click on them. So you have the number, the spacing, and the coordinates and diameter. You can also change the pattern here. So we have already this pattern. And also for this, again, you have 13 of them, 200 millimeters. And the exterior one. So this is the design, concrete design by ADA. To view the interaction curves, you can also use this menu here, results, interaction curves. So as you see here, we have the interaction curves for this column. For this cross section, and the second one. And you can also see the general results. You have everything here. The member number is 1, this column. You have the location on the member, and the internal forces and resistances due to steel and concrete. And also you have here the design load rate. So this was the results for our column. And if I close this window and come back to the ADA model, if you double click on the beam, you will have the beam design. So as you see, it's ADA has designed completely our beams. You have the reinforcements, the dimensions. And if you want to have a section on the beam, you can always just go to rebar placements, cross sections, You can generate even like this. Okay, so you will have 3 already generated, and these are the rebars and stirrups. You have the dimensions there. And if you want to check for the diagrams, beam diagrams and resistances, you can go to view options. Because it's not a column, I uncheck this one and I'm gonna use all of the beam diagrams. So for this example, I'm just going to use the important ones. Okay, so as you see here, for our beams, these are the curves. This is the MRX, and the other shear. As you see here, maybe we have a problem with this reinforcement here. As you see, we need to make the section a bit more stronger. So to do that, you can edit it right now here in ADA. For example, I'm going to select this longitudinal rebar here. And I'm going to make it 2. As you see, there's only one here. And because right now it is 2, we need to give it a x beginning and x end. X is this is the local axis of the beam. So x is the strong axis, this axis, and I'm going to put this a bit higher because we have 350. So right now minus 50 by 50. Okay, as you see here, they are all separated. I have 2 reinforcement here, and my beam is a bit more stronger. You can even change those to 3 or more, or you can change these too. So you can do the edit here, the rebar placement window. So let's say I'm going to put 3 rebars here. 75 to okay, so I have 3 rebars here. And right now, as you see, the strengths are okay. You can do all of these addition also for the stirrups. For example, if you just click the stirrups here, you can change the spacing, the numbers, or the size, and ADA will correct the diagrams and the resistance diagrams here according to your modifications. So you can have the results here, also general results. As you see here, I have 2 yellow rows here, which says that I have insufficient design load rate in both ends of my beam. So we need to strengthen our beam in two ends, as you see here. So I'm going to also put more reinforcements here. So here, instead of 2, we can change it to 3. So as you see, it's here almost, and for this side also. So it's okay. And right now, if I check the results again, you cannot see those yellow rows because the beam right now it's okay. And it's on 95% design rate. Okay. Okay, another feature that we have here in ADA is the bar list. So if you go here and reinforcing bar list, you will see all of the rebars that have been used in this beam, and here you have the total. It's 20 kilograms, and here you have all of the shapes and lengths that have been used in this beam. So this is a kind of schedule that is very helpful to transfer the project to AutoCAD or some drawings. So the cross sections we already explained. You can provide them here. The view options is the most important one here. You can change the fonts and these dimensions here from this dialog box, and the colors also, that if you want to change the colors on the diagrams or the text, you can always use this tab here to change it. So if I close this window, as you see, the modifications has already applied on the model, and right now you can check the deflection and other results for this beam or for this frame. Let's say under this. And you have other results also here in concrete, and load combinations if you want to check for internal forces, node displacements, and other results. Okay, this was a quick session on concrete design in ADA. So if you have any questions regarding this session, please let me know. You can send your questions or even your model to our email, tech support email that you see here. Thank you very much.